Oh, hey! You're just in time. I'm starting to work on this next challenge. And just when I thought I'd seen it all when it comes to equations, I see this. Are you ready to tackle this with me? So, I found this box, which I assume holds more pieces to this puzzle, but check this out. It has 4 padlocks. I also found these 6 keys with it, and each key has a number. I'm thinking that if we solve these equations, hopefully they'll tell us which of these keys will unlock this box. So, in all of the equations we've solved so far, and there have been a lot, we haven't seen a variable raised to the second power. In fact, we've only worked with variables raised to the first power. So, what should I do with x squared plus 1 equals 37? Well, when we're solving equations, we're using inverse operations to get the variable by itself. Let's start with our typical approach and see what happens. What is happening to x? We're squaring x and adding 1. How can we undo these operations? The inverse of adding 1 is subtracting 1. But what's the inverse of squaring x? Oh, you're right. We take the square root to undo the square. Let's try it. Start by subtracting 1 from both sides. So x squared equals 36. Now we'll take the square root of both sides. Recall that a square root is the number or variable that multiplies by itself to equal to the value inside the radical symbol. So, when we put the radical around the x squared like this, we're really asking, what times itself equals x squared? The square root of x squared is just x. And what is the square root of 36? Or what number times itself is equal to 36? Yes, 6 times 6 is equal to 36. But wait, doesn't negative 6 times negative 6 also equal 36? Interesting. Maybe we should check both of these answers to see if they make our original equation true. Pause the video now and evaluate this equation when x equals 6 and x equals negative 6. What'd you find out? When I substitute 6 for x, I get 6 squared, which is 36, plus 1, which does in fact equal 37. When I substitute negative 6 for x, I get negative 6 squared, which is positive 36, plus 1, which also equals 37. So both 6 and negative 6 are solutions to this equation. Okay, so to solve this first equation, we isolated the variable and then took the square root of both sides to undo the square. When I took the square root of a number, I had to include the positive and negative roots in my answer since both values satisfy the equation. Let's try a few more examples. P squared over 4 equals 16 and 2m squared minus 5 equals 13. Pause here and give these two equations a try. Then come back to check your work. To isolate p squared, I multiplied both sides by 4. That gave me p squared equals 64. Then, to undo the square, I took the square root of both sides, which gave me p equals 8 and negative 8. For this equation, I started by adding 5 to both sides. That gave me 2m squared equals 18. Then, I divided both sides by 2 to get m squared equal to 9. Finally, I took the square root of both sides to get m equals positive 3 and m equals negative 3. Is that what you had? If not, pause here and correct any errors. We have one last equation to solve for before we can open the box. B squared plus 4 equals 16. What would you do first? Yep, let's subtract 4 from both sides. So b squared equals 12. Now we'll take the square root of both sides and get b equals the positive and negative square root of 12. What number times itself equals 12? Oh, wait a second. 12 isn't a perfect square. So is this the answer? Not quite. I think we can simplify this radical further. Recall that whenever we take the square root of a non-perfect square, we should check to see if it has any perfect square factors. One way to do this is to list the factors and identify any perfect squares. What are the factors of 12? 1 and 12, 2 and 6, and 3 and 4. Do you see any perfect squares? Yes, 4 is a perfect square. So we can rewrite the square root of 12 as the square root of 4 times the square root of 3. 4 has two square roots, positive 2 and negative 2. So our answer becomes positive 2 square root 3 and negative 2 square root 3. Pause the video here and record any notes or correct any errors before we move on. Time to put our work to the test. Which of these keys do we need to use? Looks like this one, this one, this one, and this one. Awesome job. We have the next few pieces for our puzzle and we tackled a new inverse operation. Great work. Today, we solved equations using a square root to undo a square. We found that when we take the square root to solve an equation, we wind up with two solutions, the positive and negative roots. Be sure to finish these notes before moving on to the online practice. And remember, math is everywhere. Keep exploring.
Hey.